Hey everybody, welcome. This week we are going to be continuing with Unit 2. Last week we looked at quadratic graphs in vertex form. This week we're going to be continuing the same vertex form, but we're going to be using a different type of graph, a different type of equation. This is going to be a square root equation. So it's going to have a different shape, but it's going to apply by the same rules, which is why they're in the same unit. This is what a square root graph would look like. There are several features on it, and it has similar things to what we saw with parabolas, which are quadratic graphs. So a square root graph, they're very similar to quadratic graphs because if you remember, like with solving, square roots and squares, they undo each other. Quadratics are squares, and so square roots, they undo each other. Those are called inverse relationships. And so they actually have very similar patterns about them. And what this graph ends up looking like is it's like a parabola on its side, but we're only going to be graphing the half of it. And we're mostly going to be sticking to the top half of it, unless there's different situations, which will come up later. Uh, and the reason for that, we're going to get into more during the next unit, and that has to do with functions and what we can and can't graph. Functions versus different types of equations. So there's a few different features here. X-intercepts, just like any other type of graph, that's where a graph crosses the x-axis. We also see y-intercepts, that's where a graph crosses the y-axis. And then lastly, we see this vertex, and that's the main thing we're going to focus on, just like with the previous type of graph, the vertex, where that's located and what happens around that vertex. So that's the key feature we're going to look for. On all the graphs we're going to look at, that's always going to be the furthest left point. And so we see the vertex is on the furthest left part of the graph. That's always going to be true for the ones that we look at. Technically, it can be flipped around the other direction so that the vertex is on the right and then the rest of the graph points towards the left. But it's just not the type we're going to look at. That's more of an advanced thing that you might see in pre-calculus or something like that. All right, so we're going to be looking at the square root equation, and it's going to be set up just like we had with the quadratic equation. We have an a, h, and k, and we're going to be learning about those parameters, just like we did with the quadratic graphs. So if I pop over to that screen, what you'll see here is I have this graphing tool, and it's really similar to the one that I had for quadratic graphs. And we're going to be using this to figure out how A, H, and K work for this type of graph. Now, just like with the quadratic graphs, we have what's called a parent graph. And that just means the most basic version of it, like the original one. You come from your parents, so like all the other graphs, they come from their parent graph, the original graph. I don't know necessarily why it originally was called that, but that's what I assume. So we have this parent graph. That's the most like basic square root graph. Those just represent square root values. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. Now we wouldn't have a value here at x equals 1, and that's because you can't take square roots of negative numbers. And so that's why we see a cutoff in the table as we get to a point where when you're calculating it, you'd end up taking a square root of a negative, which doesn't exist. So that's called undefined. So technically, I guess they do exist. It's called imaginary numbers. Again, another time. That's like pre-calculus stuff. All right, so then we have the parent equation, and that's going to be same setup with the quadratic, where we have a is 1, h is 0, and k is 0. So we're going to look at what these different letters do. And like I was just saying, when a is 1, h is 0, and k is 0, that represents the parent situation, the just like original graph. So when we have a equals 1, let's zoom this in a little bit here. That's going to be just the parent graph. So that's like not affected by anything. It's just original, basic like that. And same thing with h equals 0. So that's also with the parent graph, h equals 0. And that just means that it is at x equals 0. And then with k equals 0, same thing. And that would mean that the vertex is at y equals 0. Because again, k tells us up and down, h tells us right and left, x is right and left, y is up and down. So those match up together. So now we'll take a quick look over at that graphing tool, and we're going to see how that works. So just like with the other graphing tool, what I can do is I can use these sliding tools to manipulate the graph and see how different things happen. The first thing that we're looking for is what's going to happen if a is more than 1. And so what I do is I make a more than 1, and I see as a increases, that graph gets taller. So we're going to add that into our notes. When a is more than 1, the graph gets taller. The way that we say that mathematically is that it stretches vertically. So those y values went up, it stretches vertically. The next one is when a is a decimal. So we'll see how that affects the graph. So a number between 0 and 1. So I'm going to take this little sliding tool and I'm going to move it so it's a number between 0 and 1. And we see now the purple graph is a little bit shorter. It's underneath there. So it's the same, it starts at the same place, but it's just a little bit shorter. So go back into those notes there. That would make the graph shorter. And then the way that we say that mathematically is that it compresses vertically. All right, going through these here. And again, these are the same thing that we looked at for quadratic. When a is negative, we'll take a look over at that. So I'm going to move my little slider tool to make a negative. And we see now the graph flips upside down. So now it's the purple graph is underneath here. And we can make it more steep, we can make it more shallow, but the idea is that when it's negative, it is flipped upside down. So now the curve is going downward instead of upward. So it's flipped upside down. And then the way that we say that in a mathematical sense is that it's reflected vertically over the vertex. But I'm not expecting you guys to use that terminology. I'm always going to let you guys know so that you guys see those words and like, oh, that's what that means. But, you know, you can use the words taller, shorter, flipped upside down. That's what anybody would use. So it's totally okay. All right, and then a equals 0, we're going to take a look at what that does. So if we move a to exactly 0, trying to get it exactly, there we go, Alex. We see now the purple graph, that is now making a flat line, which is not a square root graph. And that's going to happen with any type of graph. If you make the a value 0, it's just going to make a flat line. It's not going to make a graph of what you're trying to make anymore. So when the a value is 0, that's just a flat line, not a square root graph. And again, that's true for literally any type of graph you can imagine. If you make an a value 0, it just makes a flat line. Always true. Okay, so now we're going to look at the h value. And again, just like we had before, that's going to affect the right and the left. And so we're just going to make sure that that's going to do the same kind of thing and what that looks like. So I'm going to set my a back to 1, which is just that normal parent graph shape. And I'm going to change my h value. First, I'm going to look at what happens when h is positive. And we see that the whole graph is shifting towards the right. So it's the same shape of a graph, but it's shifting towards the right. And then if I make this negative, it's the same shape of the graph, but it's just shifted towards the left. So that's just going to affect right and left. So I'm going to go back into here. When h is positive, that is going to shift the graph right. And when h is negative, that shifts the graph left. So it just moves that vertex right or left. And one of the things to make a note of, just like with the quadratic graphs again, is that there's that minus that's already a part of the equation. And so when you have that minus that's already in there with the h, it's going to flip the sign when you make the actual equation. And so we'll see that when we're doing the actual equations on the next couple pages. The last one is k, and again, same idea. We've done this before with the quadratic graphs. It's going to affect the up and down movement. When we shift k up, the whole graph moves up. When I shift k down into the negatives, the whole graph moves down. So it literally just moves it up and down like that. Move that back to 0. All right, going back into the notes here. And so for k, when it's positive, it goes up. When it's negative, it goes down. Okay. So pretty straightforward. And then one thing just to keep note of, if it's easier for you to think about it this way, the data point of the vertex, wherever that vertex is, the x and the y there, that's going to tell you your h and your k. So whatever the x value is of your vertex, that's your h. Whatever the k value or the y value is of your vertex, that's the k. Okay, so that's just going to match up your h and your k. That's just the x and the y of the vertex. All right, so next we will be getting into part 2, which is how to apply this to actual graph. All right, so now we're going to be looking at how to apply these three letters to actual graphs of square root equations. And so we're going to go through, I have these typed up notes that I had on here that you can look through, but I'll also go through actual examples. The rules, though, are exactly the same as what we saw with the quadratic graphs. It's the same rules, which is why this type of format of equation is so helpful because again, we can just keep applying the same rules to lots of different equations. You can apply it to absolute value, to cubic, to cube root, to exponential. Like there's pretty much anything you can imagine you can apply these rules to. So that's why they are so helpful. All right, so finding the A is the same, finding H and the K is the same as we've gone through. So we're going to look at some actual graphs on here and see what we can do about those. Go through and find the equations real quick. Okay, so on my little tablet here. So first I'm going to look at this one that is furthest to the left. And when I am finding an equation, I'm going to go through a couple of steps. Step one is I locate the vertex. And like I was saying, on these ones, it's always going to be the point that's furthest to the left on the graph, but a good way to look at it is also where the graph stops. So the graph, it looks like it continues down to the right, but there's like this stop point, like a point where it stops on the left. So that's a good indicator. That's the vertex. So in this case, it would be right here. So once you have that vertex, you're going to look 1 unit to the right of the vertex. All right. And that's going to work for most type of graphs, this rule that I'm using, this little trick. It's going to tell you what the A value is by measuring how far up or down it takes you to get towards the graph. So here I had to go down 2 spaces to get to the graph. And so my A is going to be -2. So however far up or down you go, that is going to be your A value. And the reason why that is that most graphs, their normal situation is that they start at 0, 0, and then the next point over is 1, 1. So in this case, square root of 1 is 1. In the quadratic case, 1 squared is 1. And so we can use that relationship to then figure out what the A value is. All right, so that gives us A. And then H and K, again, those are the X and the Y value of the vertex. So for H, I'm going to look at this x-axis here, and I'm going to see where the vertex is on the x-axis. In this case, it's at 0 on the x-axis. I'm looking for that yellow dot I originally made. That's at 0 on the x-axis. So I'm going to put in a 0 here. And then K is, where is the vertex on the y-axis? What does it line up with on the y-axis? So we've got our y-axis here, and that lines up also with 0. And so once you have those 3 numbers, then you're just putting them into your equation. Just like if you had a linear equation of y equals mx plus b. Once you have your m and your b, you plug them in. Same thing here. We're just plugging in these numbers now. So I'm going to take my A, that goes in front. Then I have my H, it's x minus H. So in this case, it's x minus 0. And then at the end, we have our plus K. So in this case, K is 0. So plus 0. All right, so we're going to try that with another graph here. So again, I'm going to look for the vertex. That happens to be right here. Then I'm going to go 1 unit to the right. I'm going to see how far up or down the graph is. So I have to go up 1 spot to get to the graph. So A is 1. Then I look for my H, which is, that matches up with the x-axis. So I look, and on the x-axis, that vertex is at -4. Now, when I put that in the equation, that's where it gets a little bit tricky because, again, we have that x minus. And so when we put in -4, those two minuses come together to make a plus. A double negative makes a positive. That's the rule there. So x minus -4 is really x plus 4. And then lastly, we have the k value. That matches up with our y-axis. So I'm going to look, see where that is on the y-axis. That's at 0. So then that completes that equation. So once you get the hang of these, like making an equation can actually go super quickly. You just need to, know these couple of steps, and then you can make equations for even really tricky graphs. So we're going to look at one more over here, and then we'll have one more page of just more advanced examples. So we've got this one here on the right. Again, I look for that vertex right here. I'm going to take my little pen tool. I'm going to go 1 unit towards the right. Then don't necessarily pay attention to little boxes. I know there's little boxes on here to show like in between points, but look where the numbers are. So I went from 0 to 1 unit over. Then I'm looking for how far up or down. That went up 1 unit. So A is 1. Then I'm going to look for my H value. So I go to the x-axis from that vertex, and that matches up with 0. And then I look at my y-axis to find what the k is going to be. In this case, it's at +2. And again, that vertex is just the H and the K. Wherever that location is, that tells you H and K. So that vertex there, that tells us H, that the data point there is at 0, 3, or 2, I mean. And that is our H and our K, 0 and 2. And so the data point of that vertex, that just tells you straight away what H and K are. So that's one way you can look at it. Okay, so we're going to do one more page here and then we will be done. I know my videos are notoriously long. I don't know how to make them shorter. I don't know. I guess it does have a lot of information. Okay, so last page here. We are looking at some more advanced graphs here. Know what I'm trying to do. I'm going to zoom in a little bit. Okay, so we're going to start again on the left side here. Okay, so I have this graph, and again, I'm going to do the same rules. I'm going to look for the vertex, And I'm going to go through those same steps. First, I'm going to go 1 unit towards the right. And then I'm going to look how far up or down to the graph. 1, 2 spaces up. And so A would be 2. And then for our H and our K, first I'm going to look for H. And so I look at the x-axis. That's at +3. And so in our equation, we're going to have minus +3. The minus is already part of the equation, and then we're putting in a +3. Then I look at the y-axis. That's going to tell me the k value. Here, that's at -4. So in my equation, it's going to be a -4 at the end. It's plus k, so if it's plus -4, it just makes it a -4. All right, middle one. Apologize, you guys have to see like the top of my forehead a lot because I'm always like looking at my tablet. Doing 2 screens. All right, so trying not to get sidetracked. All right, so we got this graph here. Got our vertex. And going to do the same rules. I'm going to go 1 unit to the right. And in this case, I went up not even a full spot. That's a half of a spot that I went up. So A would be 0.5. You could have also written that as a fraction as 1/2. That's fine too. Usually if you're typing things though, a decimal is easier to type. All right, so now I'm going to look for my H and my K. So if I look at the x-axis, that matches up with -4. If I look for the k value, that's at +1. So again, I'm going to go into my equation. And this is another situation where we're minusing a negative, and that happens sometimes. So it's minusing that -4. And when you minus a negative number, the 2 minuses come together to make a plus. And so that's going to be +4. And then at the end, we have whatever the k is, which is a +1. So that's a +1. All right, so one more, and I'm going to move my face again so my face is not in the way. Okay, there we go. All right, so on this last one here, we've got our vertex here. And sometimes it is on these axes, and that might actually be harder for you guys. I don't know which one is harder, having it in the middle of these graphs or right on an axis. Yeah, maybe one of them is easier. So we have this vertex here. It's right on the y-axis. Again, I'm going to go 1 unit to the right. And in this case, I had to go down 1 to get to the graph. And so A is going to be -1. And then I am looking for the x and the y value of the vertex. That's going to tell me my h and my k. So I look from the vertex, I just kind of go till I get to the x-axis, and I see that that lines up with 0. And then I do the same thing for my y-axis. Now in this case, I don't have to go very far because I'm already touching that y-axis. And that tells me on the y-axis, that's at -2. So we have in our equation, our h is 0, and then our k is that -2. So that's just going to go in as a -2 at the end. Okay, so that is all about how to write these equations, how to use them. Also, I know that there are some people that are not actually students at Jefferson High School that are watching my math videos. And if so, you could totally use any of these things. That grapher tool that I made, the link, I'll put it in the video. So if you need that grapher tool, you can use that too. So have fun. That's it. That's the whole video. The end.